The chapter name is Rational Numbers. Before we go to the rational numbers, let us recall what you all learned in the lower classes. So, first one, you have studied about the natural numbers. The natural numbers are also called as counting numbers. The numbers that are used for the counting purpose, they are called as natural numbers. That includes 1, 2, 3, like this. These are all called as counting numbers, are also called as natural numbers. The symbol we use to represent the natural numbers is n. Where it will be in our daily life, we will be using this one for counting the cattle, counting the weight, counting the trees. So many places we are using. That's why it is also called as counting numbers. So here is an example. You see, we use in algebra an equation here. X plus 2 is equal to 13. Look at this equation. When you solve this one, what is the value of x? You will get x is equal to 13 minus 2. X is equal to 11. So look at this. 11 is a natural number. It is found in this group. So we discussed this is one kind of number. It includes only 1, 2, 3, 4, 5, like that up to infinity. You will get this is called as natural numbers. Then later, man invented one more number along with these natural numbers, that is called as 0. So when he included 0 to natural numbers, he thought that all the numbers we discovered, and he called it as a whole number. And the symbol they used it is W. So W is the symbol we use to represent the whole numbers. These whole numbers includes 0, 1, 2, 3, like that. So along with the natural numbers, if you include 0, then it gives you whole numbers. Look at this one example. In mathematics, x plus 5 is equal to 5 is an equation. If you solve this x plus 5 is equal to 5, you see what happens. So 5 minus 5. So x is equal to 0. So 0 is a number. So that is included in the whole natural numbers to make whole numbers. Natural numbers along with the 0 gives you the whole number. Set of natural numbers along with 0. Okay. It is a number, 0 is the number used to represent nothing. If there is no money with you, then we say 0 amount. If there is no cattle in your home, then 0. So this is used to represent nothing. So you can see so many examples in our daily life where we use 0. Okay. So let us listen all what you have learned in class 7th or 6th itself. So now come to the next situation where the man invented the negative numbers along with these whole numbers. 0, 1, 2, 3, that is whole number. This group is whole number. Along with that, man invented the negative numbers. So let us take one example where the negative numbers are used. Look at this equation. X plus 18 is equal to 5. X plus 18 is equal to 5 is an example here. If you solve this, what you will get, you see. X is equal to 5 minus 18. You are getting x is equal to minus 13. So this minus 13 is not found in natural number, is not found in whole numbers. So it is a new number. So these type of numbers, negative numbers, minus 13, minus 12, minus 11, minus 10, minus 1, minus 2, all these numbers together we call them negative numbers. So okay, so negative numbers. So integer is a set of all positive numbers, negative numbers, including 0, whereas 0 is a neutral number. It is a neutral number. It is neither positive nor negative. It is not at all positive, it is not at all negative. It is a neutral number. So this neutral number, this negative numbers and positive numbers, this set we call it as integers. Okay. So the next, later after finding that the negative numbers, there was one more situation. Look at this example now. In our daily life we get some situations where 2x plus 3 is equal, 2x is equal to 3 is an example here. If you solve this 2x is equal to 3, what happens? X is equal to 3 by 2. See, this 3 by 2 you don't find in natural numbers, you don't find in whole numbers, you don't find in integers. This forms a set of another type of numbers. So look at another example. 5x plus 7 is equal to 0. When you solve this, x is equal to minus 7 by 5. This number also you don't find in natural numbers, whole numbers or integers, any one of the groups. You will not find such type of numbers. So these type of numbers, 3 by 2, minus 7 by 2 or 3 by 4, like this type of number leads to collection of numbers which are in the form of p by q. which are in the form of p by q, that means numerator and denominator, such numbers are called as rational numbers. We call that as rational numbers. So it is this type of numbers lead to a discovery of another type of numbers that is called as rational numbers. This is the number we are going to learn in this chapter, rational numbers. So rational numbers is a set of numbers which can be expressed in the form of p by q. See, this is the definition can be written like this: the numbers which are in the form of p by q. P by q means it is only a symbol. It is nothing but the numbers which can be expressed in the form of numerator and denominator, where p and q are integers. P and q belongs to integers and q should not be equal to 0. Why q should not be equal to 0? Suppose if I write 3 by 0, what happens? It is not possible to divide a number by 0, so therefore it is not defined. 3 divided by 0 is not defined, therefore you should not take 0 in the denominator. The numbers of this kind, we call them as rational numbers. Any numbers which are in the form of p by q are called as rational numbers. What are that p and q? They are integers. That means positive numbers, negative numbers and 0. But one condition, denominator should never be 0, because it is not defined. You cannot divide any number by 0. And the symbol we use here, the q. Q is the number symbol we use to represent the rational numbers. You understood what is rational number? Okay. Now let us see some properties what we discussed in the lower classes, and the same properties we will check it for the rational numbers. So what are the properties that we studied in class 6th and 7th? Do you remember closure property? Do you remember what is closure property? You studied this for whole numbers. You studied. So what is that a plus b is equal to c? Let us see once again. See, closure property means you take any two numbers, add them. If you get the same type of number, then it is called as closure property. Closed under addition. See, I will take whole numbers. Whole numbers, you know what is that contains? It contains 0, 1, 2, 3, like that, infinity, up to infinity. Among these numbers, you can select any two numbers. Select any two numbers. So I have selected 2 and 5. And what is the operation that I have done? Addition. 2 plus 5 gives you 7. 7 will be there in this whole number also. 0, 1, 2, 3, 4, 5, 6, 7 will come later. So therefore, 2 plus 5. You have taken two whole numbers and you have added them. The result that you are getting is also a whole number. Therefore, we call this is closed under addition. Whole numbers are closed under addition. That's why I have written addition. What is the operation that we have used here? Addition. So take any two whole numbers, add them. The result you are getting is also a whole number. Then we call it is closed under addition. First one we completed. Whole numbers are closed under addition. Now let us see under subtraction whether it is closed or not. Take any two whole numbers. I have taken 2 and 5. You can take any number. Subtract them. 2 minus 5 you make it. 2 minus 5 minus 3. Minus 3, you will not see that number in the group of whole numbers. Is it there? Minus 3 is there or not? In the whole numbers? It is not there. Whole numbers contains only this positive numbers and a neutral number 0. But you are getting 2 minus 5 is a negative number. So therefore, negative number is not found in this whole numbers. So therefore, it is not closed. But if you change 5 minus 2, it is 3. It is there. But you take 2 minus 5, you will not get that number in this whole numbers. Therefore, it is not closed. Okay. So whole numbers are not closed under subtraction. So okay, let us come to this multiplication now. Multiplication. Take any two whole numbers. Take any two whole numbers. Select any two whole numbers here. I have selected 2 and 5 only. Multiply them. The product you are getting is also in one number. 2 into 5, 10. 10 is a whole number. 2 into 3, 6 is a whole number. 0 into 1, 0 is also a whole number. Any two whole numbers from this group, multiply them, the result is closed. So here it is closed. Second one is not closed. First one is closed. Third one is closed. Come to the division. I have selected 2 and 5. 2 divided by 5. So you are getting the form of 2 by 5. So it is not a whole number. 2 by 5 you will not see in this group of whole numbers. Therefore this is not closed under division. The whole numbers, I am talking about only whole numbers. Whole numbers are not closed under division. Now in the similar way, you can check for the integers also. I am not checking. That's an activity for you to check whether this property, closure property, holds good under addition, subtraction, multiplication, division for integers. You need to check whether closure property under addition holds good for integers or not. Subtraction, it's holds good or not. Third one, multiplication, division. All these four you have to check and see that which one holds good, which one will not hold good. So therefore, so these are the closure property for whole numbers. Now integers I have given an activity to check, as already you have learned in class 8. Now come to this rational numbers. As I said, rational number, what is that contains? So you can see only the numbers in the form of 3 by 4, 2 by 3, so 1 by 4, such numbers. So that means in the form of P by Q. Remember, any numbers in the form of P by Q is rational number. Can you tell me, 3 is rational number or not?
Yes, sir.
Why it is a rational number? Why it is a rational number? Can you express that in the form of P by Q?
Yes, sir.
3 by 1. You can write it as 3 by 1. So therefore this is also a rational number. So all natural numbers, whole numbers are all rational numbers only. So now let us check the closure property under addition for the rational numbers. I have selected now to the class 8 topic now, rational numbers. So let us verify the closure property. Take any two rational numbers that you like. Now I have selected 3 by 8 and 5 by 7, minus 5 by 7. So under addition I told, let us add these two numbers. What is the LCM of 8 and 7? It is 56. 56 is the LCM. So add this one. 8 7s are 7 into 3s are, it is 21. Then plus sign you write as it is 7 into 8. 7 8s are 56. 8 into 5, it is minus 40. 8 into minus 5, it is minus 40. So what is that numerator you are getting? Minus 19 by 56. Look at this, this is a rational number. It is in the form of P by Q. So this means, so you have selected two whole numbers, rational numbers, and you have added them because the operation you are performing is addition. Sum of any two rational numbers is also a rational number. So you can write sum of any two rational numbers. Rational numbers is also a rational number. Is also a rational number. Therefore, rational numbers are closed under addition. Rational numbers are closed under addition. So this is a conclusion you have to write. Select any two rational numbers from the group of rational numbers, any two rational numbers. Add them. What the answer you are getting is also a rational number. You can verify any rational numbers, it is always a rational number only. So therefore we can conclude like this. This is the statement. You can write here saying sum of any two rational numbers is also a rational number. One example also I have given. You can check it with another example whether you will get the sum as a rational number or not. So once again I repeat, sum of any two rational numbers is also a rational number. Therefore, rational numbers are closed under addition. So the next operation that we are going to check it is subtraction. So you have selected two rational numbers. This is one rational number and this is another rational number. So first one is minus 5 by 7 and the second one is 2 by 3. Subtraction means minus. The operation that I am doing here minus. So LCM for 7 and 3, it is 21. It is 21. So divide this one. 7 3s are 3 into 5 minus 15. You write this minus as it is here, minus sign. So okay. Then divide this. 3 7s are 7 into 2, 14. So minus 15 minus 14, it gives you minus 29 by 21. See that this is also a rational number, which is in the form of P by Q. P by Q. So therefore, here look at this, even under subtraction, this is holds good, this property holds good. Okay, subtraction, say rational numbers are, what is that? Closed under subtraction. Okay, the rational numbers, you can write the conclusion, the rational numbers are closed under subtraction. So we have verified the closure property of rational numbers under the operation subtraction. So we performed the operation subtraction and verified that one. Take any two rational numbers, subtract one from the other, and the answer that you are getting is also a rational number. Therefore, rational numbers are closed under subtraction. The conclusion is this one. Okay, so let us go to the next operation. What is the next operation we have to take it? Subtraction over. Now, under multiplication. Okay, now again under multiplication you need to select any two rational numbers from the group of numbers which are in the form of P by Q. Numbers which are in the form of P by Q. I have selected minus 2 by 3 and 4 by 5. Multiply this one. Multiplication is very simple. Multiply the numerator and then multiply the denominator. So minus 2 into 4, minus 8, 3 into 5, 15. Look at this, the solution, the product you are getting is also a rational number. So therefore you can write the product of any two rational numbers, the product of any two rational numbers is also a rational number. So therefore, the rational numbers are closed under multiplication. So this is the another important property that we verified under multiplication. Closure property we verified under multiplication. Select any two rational numbers that you like. Multiply them, find the product. What the answer you are getting is also a rational number. So therefore, all numbers are closed under multiplication. So this is the third operation. The only one which is left out is, see, this is closure property for rational numbers is closed under addition, closed under subtraction, closed under multiplication. Let us see for the last one whether it is closed under division or not. Take any two rational numbers and divide. So what you are getting, let us see now. See, minus 5 by 3 is one rational number and 2 by 5 is another rational number. We are dividing. The operation that we are doing here, division. So once you divide, minus 5 by 3 you write as it is. Change this one to multiplication form. Then the numerator becomes denominator, denominator becomes numerator. Divided by 2 by 5 means if you change it to multiplication, it becomes 5 by 2. 2 by 5 becomes 5 by 2. Now simplify this one, multiplication now. 5 5s are 25, 3 2s are 6. Again look at this is a rational number. When you multiply two rational numbers, you are getting a rational number only. When you are dividing a rational number by another rational number, you are getting a rational number only. But one exception is there. This is minus 5 by 3 is a rational number divided by 0 is not possible. 0 is also a rational number. This is not defined. This is not defined. See, a rational number divided by 0 is not defined. So therefore, you can, even one example is enough to show that it is not closed. So here 0, if I take, 0 is also a rational number. When you divide a rational number by 0, then you are not getting an answer. That means it is not possible to divide. Therefore, this rational numbers are not closed under division, even though it satisfies all other numbers except 0. You can take the 0 in the numerator, but you cannot take 0 in the denominator. So any rational number divided by another rational number should give a rational number, but here a rational number divided by another rational number, that is 0, you are not getting answer, that is not defined. Therefore, this entire property, not entire rational numbers, they are not closed under division. See, we checked the closure property completely. So closure property means selected any two rational numbers, added them, getting rational number, therefore they are closed under addition. Subtraction, selected two rational numbers, then you subtracted one from the other, you got the rational number, therefore it is closed under subtraction. Then come to the multiplication, selected two rational numbers, then multiplied them, the product you are getting is also a rational number, therefore it is closed under multiplication. The last property, under division, selected two rational numbers, divided and you got for all numbers but except 0. So in this case, this is not allowing us to this rational numbers to become closed here. So this 0. So therefore, because of this 0, the rational numbers are not closed under division. Only because of 0, this property is not possible here. It is not closed under division. You got it? Closure property only for this rational numbers. First three operations it is closed. Only the last operation it is not closed. See the commutative property of this rational numbers. Before that, let us see for the whole numbers. What is that commutative property? So commutative property of whole numbers. You know whole numbers are 0, 1, 2, 3 like that. It is going up to infinity. Now from this group you select any two numbers. I have selected 0 and 7. Add them. Interchange the numbers. 0, 7. Addends you are interchanging. Addends are interchanging. 0 plus 7 becomes 7 plus 0. The answer is 7 only. So therefore it is commutative. Whole numbers are commutative under addition. Come to this subtraction. Select the two numbers from these whole numbers. 5 and 3. 5 minus 3. Answer is 2. 3 minus 5 minus 2. So 2 is not equal to minus 2. Therefore this is not commutative under subtraction. It is not whole numbers. Whole numbers are not commutative under subtraction. Okay. Come to the multiplication now. Power 5 into 3. Selected two numbers 5 and 3. Multiply, what is the product? You are getting 15. Interchange them. Multiplicand and multiplier are interchanged. 3 into 5. So you are getting the same answer. 3 into 5 or 5 into 3. Both are same. Therefore, it is closed under this commutative property of whole numbers under multiplication. Holds good here. 5 into 3, 3 into 5 is equal to 15. Therefore, whole numbers are commutative under multiplication. Whole numbers are commutative under addition. Whole numbers are not commutative under subtraction. Come to this last operation. 5 by 3 is not equal to 3 by 5. Therefore, whole numbers are not commutative under division. See, this is the commutative property. What is commutative property? If A plus B is there, then it should be equal to B plus A. Addends are interchanged. Suppose A into B is there, then you have to make it B into A. If that is same, then we call. This is only under addition. Okay, so we have performed all the 4 activities and checked that one. It is commutative under addition, it is commutative under multiplication, but not commutative under subtraction and division. So this is for only whole numbers. Now come to the 8th class topic, that is rational numbers. So let us check for the rational numbers. Commutativity of rational numbers. So rational numbers, you know that again I recall one, it is number in the form of P by Q. Select any number which are in the form of P by Q. I have selected minus 2 by 3, minus 2 by 3 and 5 by 7. take the LCM and add. 7 3s are 21. LCM is 21. Simplify this one, you will get the numerator 1. Since it is a lower class topic, I am not going in detail. So now, if you simplify, minus 2 by 3, when you add that one to another rational number 5 by 7, you are getting 1 by 27. Now interchange the addends. Minus 2 by 3 you write here, 5 by 7 here. 5 by 7 in the first, second place 2 by 3. Add them now. Again you are getting 1 by 21 only. So in both the places you are getting 1 by 21. So therefore you can conclude that rational numbers are commutative under addition. So you can conclude that rational numbers are commutative under addition. So it holds good. This property holds good under addition. Commutative property holds good under addition for rational numbers. So okay. Now under addition over, let us see under subtraction now. Select any two rational numbers. I selected 2 by 3 and 5 by 4. One rational number is subtracted from the other. 2 by 3 minus 5 by 4. So what is that you are getting? LCM is 12. 12 is LCM. 3 4s are, 4 2s are 8. Then 4 3s are, 3 5s are 15. 8 minus 15. You are getting minus 7 by 12. Now interchange this subtrahend and minuend. So when you subtrahend and minuends are interchanged, so what happens here? 5 by 4 here, 2 by 3 here. Subtract this one. What is that you are getting? 7 by 12 only, but sign is different. This is minus 7 by 12 and this is plus 7 by 12. They are not equal. So therefore, this rational numbers are not commutative under subtraction. You can write rational numbers are not commutative under subtraction. So this property holds good under addition but not under subtraction. You cannot interchange the subtrahend and minuend. You cannot interchange and subtract. It is not possible. But you can add in any way. You can add the numbers, rational numbers in any way, but you cannot do the same thing under subtraction. You cannot interchange and subtract. So you are not getting the same answer. Minus 7 by 12 is different from plus 7 by 12. They are not equal. So therefore, it is not commutative under subtraction. So now subtraction is over. Let's go to the next operation. Next operation, that is multiplication. So you select any two rational numbers which are in the form of p by q. I have selected 7 by 3 and 6 by 5. Multiply them. What is the product you are getting? Minus 42 by 15. Multiplication is very simple. Multiply numerator with numerator, denominator with the denominator. 7 into 6, 42. Minus sign. 3 into 5, 15. So you are getting minus 42 by 15. Now interchange them, multiplicand and multiplier. If you interchange the multiplicand and multiplier, see minus 7 by 3, I have written the second place, 6 by 5 plus in the beginning. So what is the product you are getting? 6 7s are minus 42, 5 3s are 15. Same answer you are getting. Even after interchanging the multiplicand and the multiplier, and you are getting the product same. So therefore, it is commutative under rational numbers are commutative under multiplication. So the product you can write in the sentence, the product remains the same even if we multiply by interchanging multiplicand and multiplier. You interchange the multiplicand and multiplier, you see the product remains same. Therefore, rational numbers are commutative commutative under multiplication. They are commutative under multiplication. See, this is another important property of rational numbers. See, we checked it. Let us recall once again for rational numbers. Commutative property. Rational numbers are commutative under addition. Rational numbers are not commutative under subtraction. So now we got rational numbers are commutative under again multiplication. Because interchange the numbers, multiplied and product you are getting same. Now the last operation for this commutative property, that is division. Select any two rational numbers. I have selected minus 5 by 4 and 3 by 7. Divide it 1. Minus 7 by 4 divided by 3 by 7. Division, you know, it is multiplication. Interchange this numerator and denominator and multiply. Both are same only. Minus 5 by 4. If you change this one to multiplication form, 3 by 7 will become 7 by 3. So here division I converted it to multiplication form. So therefore 3 by 7 is changed to 7 by 3. Now multiply. 7 5s are 35, minus 35, 4 3s are 12. So you are getting minus 35 by 12. What is the next thing? You interchange this dividend and divisor. This is dividend, this is divisor. Interchange the dividend and divisor. So this 3 by 7 will become dividend here and minus 5 by 4 will become divisor here. So then again you change this division sign to multiplication, interchange this one. So it becomes minus 4 by 5. 4 3s are 12, minus 12, 7 5s are 35. So look at this one. Minus 35 by 12 is not equal to minus 12 by 35. They are not same. So therefore here the rational numbers are not commutative under division. You are not getting the same answer. So conclude that rational numbers are not commutative under division. So we studied closure property, we studied the commutative property. So under commutative property of rational numbers, it is commutative. Rational numbers are commutative under addition, rational numbers are commutative under multiplication. But rational numbers are not commutative under subtraction and division. So holds good in two places and not holds good in another two places. Addition and multiplication commutative, subtraction and division not commutative. Okay, so this is about the rational, this commutative property. There is one more property. Tell me what is that one more property? What is the one more property? Closure property over, commutative property over. What is that next? Akshata? Associative, good. Associative property. Let us check the associativity now. Associative property, recall for the whole numbers. Before we go to the rational numbers, as you studied these whole numbers in 6th and 7th, let us recall once again what is associative. So you need to select whole numbers means a set of whole numbers contains 0, 1, 2, 3 like that up to infinity. Among these numbers, select any three numbers, multiply them. First you multiply 5 and 3, you will get 15. Then you multiply to 2, you will get 30. Now instead of multiplying 3 and 5, you multiply 2 and 3. Group them in different ways and multiply. First we grouped here 3 and 5, multiply. Now I am going to multiply them by grouping in different way. So 2 and 3 grouped together and multiplying. 2 3s are 6. Then afterwards I am multiplying to 5. So here also 30 only. Here also 30 only. Group the whole numbers in different ways as you like. And simplify that one. You will get the product same. Okay, so not addition, sorry, this is under addition, not multiplication. Plus sign. So you write plus sign here everywhere. Group them in different ways and add them. So 3 plus 5, 8. 8 plus 2, 10. Come to this one. 3 plus 2, 5. 5 plus 5, 10. Group the whole numbers in different ways and add them, the sum remains same. So therefore, whole numbers are associative under addition. Whole numbers are associative under addition. Plus sign. Okay. Now come to the subtraction now. First you group 3 and 5 here. 3 minus 5. What is the answer? It is minus 2. So then minus or minus plus. Plus 2 it gives plus 4 here. Come to this side. This side plus 4. 2 minus 3 minus 1. Minus 1 minus 5 minus 6. So you are not getting the same answer under subtraction. So you cannot group the whole numbers in different ways and subtract. You cannot do that one. So this is not holds good under subtraction. Associativity is not possible under subtraction. Come to the multiplication now. Take any three whole numbers, multiply them in different ways. In the first part I have multiplied 3 and 5 first, then to 2. 3 5s are 15, then 2, 30. Here 2 and 3 first, then 5. So here you are getting the same answer. Even you can multiply 5 and 2, then 3, then also you will get 30 only. So that means all numbers can be grouped in any way, the product is always same only. And multiply or addition only holds good under addition and multiplication. It is not possible even under division. Divide this by grouping them in different ways. This is not possible. So it holds good under addition, it holds good under multiplication, but not under subtraction and division. So this is only for whole numbers, class 7th topic. The same property, let us check it for rational numbers. Okay, associativity of rational numbers. So select any three rational numbers. I have selected here, look at this, 1 by 2, 1 by 4, 2 by 3. I grouped 1 by 4, 1 by 4 and 2 by 3. So I simplified this one. It is giving you 3 plus 8 by 12. Take LCM 12. So it becomes 3 plus 8. So 1 by 2 plus this will become 11 by 12. So answer you are getting 17 by 12. Now instead of grouping this, let us group these two first. 1 by 2 plus 1 by 4. Then it becomes 3 by 4. 1 by 2 plus 1 by 4, it becomes 3 by 4. Then add to the second number, third number, 2 by 3. So it becomes again 17 by 12. So you group these rational numbers in different ways. First 1 by 4 and 2 by 3. Then to 1 by 2. Here 1 by 2, 1 by 4, then to 2 by 3. Any way you can select the numbers and add them, the sum is always same. You are getting 17 by 12 only. Take any way you can group and add them, the sum is always same. So that's why this is associative under addition. Rational numbers are associative under addition. So let us go to the next operation, subtraction. Subtraction now. So I have selected three rational numbers, 3 by 4, 1 by 4, 2 by 3. First I grouped 1 by 4 and 2 by 3. When you subtract this one, you will get 3 minus 8 by 12. This I have written as it is. This simplification is like this. Then this 3 by 4, this is minus 5 by 12. Once you add them, so you will get 9 plus 5 divided by 12, it is 7 by 6. You know how to subtract and all. Simplify this one, you are getting 7 by 6. Now instead of this group, let us take the first two groups, 3 by 4 and 1 by 4. Simplify this 3 by 4, 1 by 4. It gives you 2 by 4. This I have written as it is, 2 by 3. 2 by 4 minus 2 by 3, if you simplify, you will get minus 2 by 12 and it is 1 by 6, minus 1 by 6. See, first we grouped these two numbers, simplified, you got 7 by 6. And here in the case, we grouped the first two numbers and then simplified, you are getting minus 1 by 6. They are not same. So therefore, subtraction is not possible. You cannot group the rational numbers in any way and subtract them. It is not possible. You will not get the same answer. So therefore, you can write the conclusion. Rational numbers are not associative under subtraction. Again, rational numbers are not associative under subtraction. Can you guess, is it possible under multiplication? The next operation, multiplication, is it possible or not? It is possible. Now again multiplication. See, 1 by 4 into 2 by 5 into 3 by 4. I selected three numbers, rational numbers. multiply 2 by 5 and 3 by 4 first. What you are getting? 6 by 10. Whatever that we have written inside the bracket, simplify, you will get 6 by 20. Then to multiply to 1 by 4, you are getting 3 by 40. Now change the grouping. Instead of last two numbers, you multiply the first two numbers. 1 by 4 and 2 by 5. So you are getting 2 by 20 into 3 by 4. This 3 by 4 as it is. Again the product you are getting the same number. So that means multiplication holds good. Rational numbers are associative under multiplication. Write like this. Rational numbers are associative under multiplication. So this is property. Now can you guess, is it possible under division? Rational numbers are associative under division or not? No. So it is not possible. Okay, now I have given one example here, simplified. You can do it later. Just look at this one. You can verify this one. You can take some more examples and verify. So I have done already for you. Look at this one. There are three rational numbers, 1 by 4, 2 by 3, 3 by 4. I simplify first by grouping these two. The last two numbers simplify first. Then divide that one, you are getting 8 by 9. Last two number simplification, you are getting 8 by 9. So this is the last row. And then 1 by 4 I have written as it is. Again if you simplify this, you are getting 9 by 32. Now instead of last two groups, you do it for the first two groups in the beginning. 1 by 4 divided by 2 by 3, you do it first. So you will get 1 by 4 into 3 by 2. Division change to multiplication. 2 by 3 becomes 3 by 2. So then this part becomes 3 by 8. And 3 by 4 as it is. Now if you simplify 3 by 8 into 4 by 3, you are getting 1 by 2. Look at this. Here 9 by 32. In the second case 1 by 2. So therefore you cannot group the numbers in different way under division also. So this rational numbers are not associative under division. They are not associative under division. So now today I'll stop here. So what are the properties that we discussed again? Let us recall once again. First one we discussed closure property. Closure property. Then second one commutative property.
Associative.
The last one we discussed associative property. Associative. Okay. Now under this again. So let us recall. Closure property, rational numbers, you tell me. Under addition. Closure or not? Rational property. Under subtraction. Closure property. Closure property I am talking. Under addition and subtraction. Subtraction it's rational numbers. Recall once again. Take any two rational numbers, add them, you are getting rational number only. Take any two rational numbers, subtract them, you are getting rational number only. It holds good. Multiplication also holds good. Okay. Division not possible. Division not possible. See, rational numbers holds good under addition. It is closure property under addition, subtraction and multiplication. But not under division, because you remember that 0. That 0 is not making the closure property there. Is it clear? Okay. Come to the commutative property. Tell me whether rational numbers are commutative or not under addition.
Yes, sir.
Under subtraction? No. Under subtraction that is not possible. Multiplication? Yes. Division? No. Division? No. Okay. So this is not possible, this is not possible, this is not possible. Now associative property. Under addition, you can group them in any way, add them, no problem. Any way you can group.
Yes, sir.
So subtraction, it is not possible. Multiplication, yes. Division, not possible. See, this is the summary what we learned today. See, closure property. Rational numbers are closed under addition, rational numbers are closed under subtraction, rational numbers are closed under multiplication, but rational numbers are not closed under division only because of that 0. 0 is a rational number. Everywhere it holds good, but except 0, it is spoiling that one. You cannot make it closure property. Come to the second commutative property. Rational numbers are commutative under addition, rational numbers are not commutative under subtraction. Rational numbers are not, they are commutative under multiplication. Rational numbers are not commutative under division. Same thing in associative property also. Rational numbers are associative under addition and multiplication. Rational numbers are not associative under subtraction and division. So that's the property. Tomorrow we will discuss the property of 0 and property of 1. All these things we will discuss in the next period. So this is the end of this today's class. Okay.